Okay, we are doing the last lesson of our linear equations unit, 5-7, scatter plots. Your learning target today, you can analyze and create scatter plots. That's what we're really doing today. We're doing line of best fit tomorrow. So today we're going to be able to analyze and create. A scatter plot is a collection of data points not connected. So it's just points randomly put on an axis. If they have a correlation, I think of relation, like a relationship. There's something going on with that. A correlation, you can tell if they have one. It looks like it can form a line. They're hanging out together. They're congested together. Here's the different types of correlation. You have a positive one, because it looks like it can form a positive line. Do you agree? You have a negative. Do you see the negative line it could form? It looks like it could form a negative line. That means as x gets bigger, the y value gets smaller. Positive, as x gets bigger, the y value gets bigger. No correlation. Do you see a line with this one? No, there's no line. Okay, there's no relationship. All right, so we're going to create a scatter plot. And our scatter plot is the dollars that we spend and the gallons bought. Okay? So I need to figure out what goes on the bottom. The bottom is the independent variable. Dollars or the gallons? What depends on the other? Okay? I would say gallons is dependent, or your money that you spend is dependent on the gallons that you buy, right? The money you spend depends on the gallons you buy. Money depends on how much gas we're putting in. Do you agree? I can put maybe a gallon in and then I only spend 5, or I can fill my car up. Okay, fill my car up, I'm going to have more money. So, dollars spent looks here like this should be then X and this is Y. We could really do this vice versa too. Let's say I only have 20 bucks to spend. Well, then my gallons is dependent on how much money I can spend. Okay, so I mean, we can really relate this in a couple different ways. So let's say that, let's look at our range. It looks like I go smallest 1.1, biggest 2.8. So I think I'm going to go by 0.25. So I'm going to range by 0.25s. Then we get 0.25, this would be a 0.5. 0.75, this would be 1. 1.25, 1.5. 1.75, 2. 2.25, 2.5. I don't include that 2.8, but I can make a good estimation. Dollars that I spend goes up to 11. I'm going to go ahead and just scale it by ones. And that way I can just go a little bit off the chart for 11. Okay. Then you just start plotting them. So when I'm at 2.5 gallons, I spend 10 bucks. So 2.5 gallons right here, I spend 10. You make a point. When I'm at 2.8 gallons, I spent 11 bucks. So 2.8 would be about right here. 11 would be about right there. Kind of looks like a line, doesn't it? 2.3, I spent 9 bucks. So this is 2.25. 2.3 would be probably right around here somewhere. It does not have to be perfect. It's an estimate. So 2.3, I spend 9. 2.6, I spent 10 bucks. Now notice they're looking close together. That tells me that I probably have a correlation. There's a relationship going on. 3.3, oh darn it. 3.3, I spent 13 bucks. I would be approximately right there. I'm off the chart. Oops. I forgot about 3.3. 1.3, I spent $5. 1.3, if this line right here is 1.25, 1.3 is just a little bit bigger. 2.2, I spent $8. That's a little bit bigger than 2, up to the 8. In 1.1, I spent $4. That's a little bit bigger than 1. Does it look like it has a correlation? Can you envision the line it's forming? I think it does. This looks like a pretty good line. If you were to connect it, looks like I could create a good line. It looks like they're going together. They're increasing together. So this would be a positive correlation. Okay? So you gotta, do you feel like you would be able to identify if it's a positive correlation, negative, or no correlation? Yeah, scale yourself. Where would you be? Could you create a scatter plot? Could you identify if it has a positive or negative correlation? That's what you wanna, that's our to do today. Okay, I want you to do this next one. Okay, so looking at this graph to plot it, or this table to plot it, I always have to identify what's the dependent and what's the independent variable. I see I'm dealing with altitude and temperature, and then I just use my personal logic to determine what's independent or dependent. And I know the higher up I am, the lower my temperature. So the independent would be my elevation or my altitude. And my dependent would be my temp. And then I look to see how am I going to scale it. And I look at my range of values and just do guess and check. Altitude, it looks like I range from 0 to 5,000. So as you can see, I started with 500, taking it off by 500s to see if it worked. And it looked like I went right to 5,000, so that's the way to go. Temperature is more tricky. I go from 0.6 to 59, so it's a little bit harder. I think we're going to go by tens. 10, 20, 30, 40, 50, 60, 70. Okay, and now I'm just going to start plotting. These are all points. So that's a 0.059. So when my elevation is 0, I'm at 59 degrees, which is right under 60. When I'm at my elevation or altitude is 500, I'm at 59.2. 500 is this first marking. 59.2, it's hard. You just put a rough estimate. It does not have to be perfect. 1,000, I'm at 61.3, so I'm a little bit bigger. 1,500, I'm at 55.5. So at 1,500, I'm at 55.5. 1,000, I'm at 2,000, I'm at 41.6, a little bigger than 40. 2,500, I'm at 29.8, so that's right before the 30. 3,000, 29.9, again right before the 30. They look identical, right? I mean, I'm not stressing out over is it perfect. It's easier to do with a pencil. You have a finer tip. You can make a better estimate. Let's see. So 3,500, I'm at 18.1. 4,000, 26.2. 4,500, 12.4. And 0.6. Does it look like I have a correlation going on? This is too big. 0.6 would be right at the bottom. Yes or no? Does it look like they're congested together? Yes or no? Can you visualize a line? Yes, I can too. Is this a positive or a negative correlation?
Negative.
This is a negative. You can envision a line that goes through. This would be a negative correlation. Next concept. Whoops. Come on. Huh. Do you guys have, you don't have this one in your notes, right? So I just want you to tell me, positive or negative or no correlation?
No correlation.
Positive, negative, none.
No correlation.
Positive, negative, none.
Positive.
Positive, you can see the positive line. Positive, negative, none.
Negative.
Negative.
Positive.
Like this is an exponential growth actually. If you can envision, it's going growing really fast. But yes, I will take positive. Positive, negative, none. The next one. Steep negative, right? None. Good job. Yay, us. It would still say good job. Line of best fit. A line of best fit, I've been drawing it since the beginning. It's a straight line drawn through as many points as possible. That's the key. You kind of want it in the center. It has approximately the same number of points above and below. So it's right in that middle ground. Okay? Can you visualize them? I want you right now to make a line of best fit with this data set at the bottom. It should go through as many points as possible. Right through the middle. I just always tell my students, look, where does it look like the middle? And I draw a little line through the middle and then just connect it all the way through. Everyone's line of best fit may be a little different. I actually didn't like that word. And that's okay. There's not exactly one line of best fit. We're going to get roughly about the same data values. We're going to be really close to each other, I have no doubt. I know somebody didn't get this. I know somebody didn't get this. Somebody got pretty close to mine. Might be a little off, and that's okay. I can tell if you were right on. Okay, here's what our last learning target for today. You need to be able to make predictions. To make predictions, we use the line of best fit. So, what do you think depends on the other, height or age? What is independent here? Age. Age is always our independent. So age goes on the bottom, height goes on the left. My age goes all the way into my 20s, so I'm thinking maybe 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There's one data value that I'm going to be a little off, and that's going to be okay. My heights range from, 50s to 68s. So maybe I'm going to do just 5. No, 5 doesn't work. I'm going to have to do 10s. 10, 20, 30, 40, 50, 60, 70. And now I'm just going to graph. So at 9, I'm 54 inches. 9 is right before the 10, kind of halfway between the 8 and the 10. I'm 54. I'm about right there. Okay. 13, I'm at 62. So 13 would be about right here. I'm at 62, which is a little bit bigger than 60. 15, I'm at 64 inches. So at 15, here's 15, I'm at 64. That's right before halfway. At 17, I'm at 68. 68 is right before the 17, or 70. 18, I'm a little bigger. And 21, I'm the same. So I need you to envision the line of best fit. This is a positive correlation. I can see the line. It's just starting to taper off because you stopped growing, right? So my line of best fit